Let's welcome Mike Maher from Maher Advanced Manufacturing.
I'm here to talk to you today about our approach to low-cost thermoforming of composites in order to be cost competitive with metals in aerospace and automotive industries. Here we have the Boeing 787 Dreamliner, which is created to be the world's most fuel-efficient commercial aircraft. This drove Boeing to using composites for 50% of the structure, but prevented further adoption was the manufacturing cost of smaller parts. In fact, there are over 500 of these small parts just located around the windows that are currently made out of aluminum. The problem with the composites today is that part sizes get smaller, costs begin to skyrocket. A recent DARPA program found that there is an inflection point, and with parts smaller than 20 pounds, automated techniques such as fiber placement and tape placement lose their effectiveness. This is because the placement head is constantly changing direction and never gets up to full speed. Without effective automation, composite parts of this side must be laid up by hand, which drastically reduces throughput to roughly 2.5 pounds per hour. Ultimately, aluminum has become the choice material for these parts due to this associated labor and material cost. Our proposed process is called wet press. First, we'll use pick-and-place robots to create a preform out of dry, open-weave fabrics. Resin is then painted or sprayed onto the preform using an automated die. Robotic grippers will then move the preform to a heated tool where a hydraulic press will close and force the resin to infiltrate. After a short cycle time of mere minutes, the part is consolidated and cured. And something that I want to point out that really sets our approach apart from traditional liquid compression molding is that by using the open weave fabrics, we can create stacks with channeled preforms, which allow the resin to infiltrate more easily, quicker, and more consistently, which ends up with a part that has less void content and lower porosity. Our process is highly automatable, and by minimizing touch labor, the anticipated throughput will be around 80 pounds per hour. This reduces the labor cost per part, as well as the material cost, by removing the need for an expensive intermediate format like prepreg. The team sees two industries where this process will make a huge impact: aerospace and automotive. And with the sweet spot for wet press being parts that are less than 20 pounds, under 7 foot by 7 foot, and with flat to slight curvature, there are lots of possible applications in both these industries. The parts in aerospace that we're going to be targeting consist of smaller structures such as hatches, access doors seen in the upper right here, and rib-stiffened skins on smaller UAVs. On the automotive side, we can fabricate doors, dashboards, and parts like seat and floor plans seen here, where these parts have just been metal stampings for decades. We anticipate the process will be cost competitive with aluminum for aerospace around $200 per pound and $30 per pound in automotive, but obviously you have all the benefits you come to expect with composites. So taking this into consideration, our team sees lots of opportunity for replacing metal components within both of these industries. Here we have some of the market analysis we performed. Obviously, these are both sizable segments, and both are fairly consolidated by OEMs, larger companies, and key players. But we're really excited because we're going into the untapped portion that is just as large, but is currently using metals like aluminum and titanium. We are currently pre-revenue with this technology, but we believe our strategy will allow us to scale quickly. Our initial focus will be on the military. And the reason we identified the DoD as our beachhead is that in certain instances, they will assist in getting the process and procedures in place in order to qualify our wet press process, which we realize is going to probably be our biggest hurdle in the upcoming years. The DoD programs that we're really looking at are your developmental programs like Mantech and LCAT, but we are also engaging with production programs like the V-22 for sustainment. We also plan to engage with future platforms like the B-21 and several of the UAVs in the next couple months. We believe that success of our process will lead to implementation. So once we have established ourselves in the DoD, we'll be able to branch out into commercial aerospace and automotive, which will take significant investment in the infrastructure of our facility in order to meet the required rates. Our revenue streams will come from direct sales into supply chains of the OEMs and lower tiers, or through licensing the IP we developed with working with the DoD. We intend to continue working with production programs to integrate our tech on the future platforms. but we also want to work with the service depots and help with the sustainment of current vehicles. Here's the team we're working with right now. Our partners come from the best of both industry and academia. Two of our team members are some of the most successful companies at incorporating composites into vehicles. Boeing in aerospace and SGL in automotive, based off their previous partnership with BMW. The other thing to note about our team is that we have partners that provide expertise in all facets of our program, from low-cost tooling, process development, qualification, all the way to system integration. BMW has demonstrated similar wet press process on the i8 at low-rate automotive production volumes. However, the process has never been demonstrated to a significant degree on an aerospace component, and therefore has never been qualified. This is why we are evaluating our technology at a TRL level of 5. Over the next 2 years, we will demonstrate this process in an aerospace application and make sure we're meeting all the qualifications in order to integrate our produced part onto an aircraft. Thank you for your time. If you have any questions or would like to discuss our approach further, please feel free to contact me or connect with us at the virtual booth later this evening. Thanks again.